Welcome to 10-2, Writing Interpreting Absolute Values. So we're going to take a few minutes and review graphing patterns of absolute value functions, and then we're going to go on to having graphs and writing equations. So we're going to go backwards. Alright, so all the graphs of absolute value functions are V-shaped. Now they can be V-shaped with a minimum or an upside down V, which means reflected across the x-axis with a maximum point. Translation of parent function, y equals absolute value of x. When I have y equals the absolute value of x, if I have plus x, or plus k, or minus k. So this is actually two things. This is the y equals the absolute value of x plus k, and what happens when y equals the absolute value of x minus k. And k, if it's outside of the absolute value, affects the up and down. So when k is greater than 0, it is going up. So it can be anywhere along the y-axis, above in the positive. And when k is less than 0, it shifts the parent function down. Then we start back again with the translation of the parent function y equals the absolute value of x. When y equals the absolute value of x plus or minus h, which can, and notice it's inside the absolute value. And again, these are actually two equations, and that says y equals the absolute value of x plus h and the absolute value of x minus h. Now h, when it is inside or protected by an absolute value, then it is messing with the x-axis and is moving left or right. And it's kind of opposite of what you think. X doesn't really follow the directions. So h is greater than 0, so when I have a positive h, you would think it's going that way, but it's not. It shifts it left. And when I have a minus h, you would think it's going that way, but it's not. It's going this way, which is right. Okay, here we go. Reflect of parent function y equals absolute value of x over the, and we don't flip over the y, we're always flipping over the x-axis. And that's not a number, that's a symbol. So it is whether a is positive or negative. So when you have a positive absolute value of x, it has a minimum. When you have a negative absolute value of x, you have a maximum. And this opens up, and this opens down. So this is left, right. This is up, down. This is min, max. And this is a sign. Okay. So here's some examples. It's sketch and graph and write an equation to match each transformation, then find each vertex. So opens down, so that's going to be a negative outside the absolute value, because opening down. Shifts 4 units to the left, so we're over here. And remember, it's the x, so x. Left you would think is negative, so it's positive. And 4. is there, and the vertex will actually come from right here. So my vertex, there's nothing here, so y is 0. Inside, it looks like a positive 4, but the vertex will be at negative 4. And so then I'm going to graph. Oh, I suppose I could have put the graph there. And so it is to the left, and that is the graph. Okay, opens up, positive, and I don't need that positive, but I'm going to put it up. And so if it's positive, it's got a vertex. There's nothing next to the x. There's the 6, and it opens up. And this is 6 units up here. And this is 6 units up. Opens up. Shifts 7 units to the left, which goes that way, which is a +7, and left is inside. The vertex, there's nothing here, so there's a 0, and this is a inside, so instead of a 7, it's a -7, and it has a minimum, and so 1, 2, 3, 4, 5, 6, 7. And this is the absolute value picture graph. Sorry. This one has a maximum because it's opening downward. This one has a minimum because it's opening upward. Okay. Opens up. 9 units to the left. 2 units down, so it is x plus 9 and a -2 on the outside. The vertex is -9, -2. Notice the sign stays, and notice the sign looks opposite. My graph, I'm going to do it up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2. Oh, should have made that a little bit smaller. Oh, opens up, opens up. Oh, I almost blew it. It opens up. So make sure, even if you're hanging out in the 3rd quadrant, that you don't accidentally put it to where it opens down. That has nothing to do with it. And it even said opens up. Didn't follow. Okay, write an equation to match the information. Opens down, leading negative. Shifts 12 units to the right. Right is that way, -12. Negative absolute value of -12. Now, notice that negative is not inside the absolute value. Opens up. 7 units to the right. Up 4. That is x -7 protected plus 4. Let's go back and we'll name our vertex. Our vertex is at 12, 0. And it has a maximum because it opens down. This has a vertex of 7, 4, and it has a minimum because it opens up.